Hello and welcome to this Marylebone Maths Hub hosted session on planning for the new A-level. We're delivering this session on Tuesday afternoon, the 24th of January, and it was originally a live session, bunch of teachers in a room last Wednesday. There were about 10 of us, and what you're going to hear are some of the edited highlights. This should take about half an hour to 45 minutes. And let's start by looking at some of the feedback we got from the first questions we asked our A-level teachers. We simply asked them, what are your concerns about the new A-level? These are the median scores that they gave. So, as you can see, everybody's a bit concerned about most of it. Two or three things were flagged up particularly. Scheme of work and links to the new GCSE. Those things are related. The scheme of work, because we don't know exactly what the specification is yet. The new GCSE, because we know what it is, but nobody's done it yet, and none of us have experienced some new GCSE graduates arriving in our A-level classes. We will be addressing certainly the links to the new GCSE in this session. And the other thing that came up a bit was this teacher CPD. The thing that people seemed least worried about was the actual maths. And given the nature of a group that comes to an A-level session, they're probably pretty good at maths, so they probably aren't that worried about what maths is involved, although we will have a little differentiation from first principles and precisely what your students are expected to know. But the first thing I'd like us to look at is a kind of overview of where we've got to the specifications, what are the big changes, and what are the issues that we should be planning for looking ahead. At the time of the live session, none of the specifications have been signed off. I think as of now, the AQA one has been signed off and the others are still waiting. I presume they will come in relatively quick succession. And Lee is going to talk through some of the issues that arise globally on these big issues to do with exam structures, exam boards, and the major changes in the specifications.
So, a couple of things have happened, by the way, since we gave the TRG last week. One key thing, of course, is we've had an industrial strategy announced. And in there, if you looked at it, it did refer to somebody called Professor Adrian Smith's report. And we have obviously had some leaks to the extent of maybe there's going to be a specialised maths secondary school in every city in the land. However, we are waiting for the official report. Professor Smith is presenting a conference I happen to be going to next Thursday, so I'm pretty certain he'll be reporting in the next week or so. In terms of where we are with the new A-level, one of the key things is it's a bit manana, waiting for Godot. We haven't got the sign-off of the specs. We are now in the stage that things are getting signed off. If you'll see on the screen there, we had last week OCR get signed off for the AS level. Now I believe they are signed off for the A level as well. It's a painful exercise, but you can go onto an off-qual site and see where everything else is. But the hope would be that now we've got one exam board signed off, the rest will follow fairly soon. One of the key things is also the further maths. In the A-level maths, in a way, it should be easy because everybody has to do the same thing. It's 100% prescribed. And yet that's taking a while. Well, the further maths, it's only 50% prescribed. So the further maths will be a little bit behind the curve, and there's a much more variability between the exam boards. And certainly we as the school will be thinking even more about the decision of which exam board we use for further maths than we might necessarily on the A-level. On the A-level side, the maths side, we currently use Edexcel. I've had a really positive experience with core maths with AQA, and I think realistically we would like to see all the exam boards. Some people are telling me they quite like AQA, but we as a school haven't really managed to evaluate yet. So what's in the new specification? Well, There are four key things. You're going to hear from Nick a little bit later on about proof in terms of first principles differentiation is a form of proof in terms of just how do you do it with various limits. Modeling is a key element, and later on we'll be looking at how modeling effectively comes into an exam paper. Problem solving, we've got a fantastic report that actually analyses problem solving. We'll mention that later, and we'll provide a link for anybody wanting to get that. But actually somebody somewhere, a very eminent board, have come up with 6 key elements of what problem solving is. It's not that you need all 6, but certainly if you've got one of them, it perhaps qualifies as problem solving. And here's a key issue that we wanted to focus on a bit today, is the technology side. Here's a plug. Friday 28th of April, teamed up with FMSP, they have a technology day of using technology in the A-level. I'm going to introduce the sorts of things that we're already using at St Marylebone, but you'll get a much more fuller in-depth insights into the range of technology at a specialist day like that. It's not a one-off, just once at St Marylebone. There are other dates. If you go on to the FMSP website, it has an incredible number of CPD activities, and some of the content that you'll see in today actually comes from FMSP and from their specialised planning for the 2017 Maths A levels. That's a half day, or it might be a full day, I can't quite remember actually, but a brilliant course. If you haven't been on it, I would strongly suggest it. The whole FMSP team have been on a road show around the UK, I think. They've done London already, but I think at some point they do come back, and I think the next one is in Cambridge, that's close to London anyway. There are other courses that are provided. FMSP tie up with MEI, and there's a whole range of excellent CPD courses which I would refer you to look at the FMSP website for the range there, and then you can sign up directly through the website. These are ones certainly that we're thinking about, and they're both online and physical. Is one of the key issues I think that seems to be coming through is people are a little bit aware that the exam boards have had to juggle around their mechanics and stats, the applied side, and in particular link it more into the pure side. So FMSP has got some specialised courses for helping people work through that, and I definitely recommend contacting them on that side. Integral Maths is another resource that there are different types of login, so it's a bit frustrating, and there's subscription rates and things like that, but that looks to us as though it's a really, really good resource. We've been using it a lot for core maths. So down to technology. Up on that screen there you'll see some key elements from our perspective to do with technology. If I look over to the left-hand side as you look, Casio, I've got a specialised calculator. A calculator that has, for instance, normal distribution tables. A calculator that can work with matrices. A calculator that when you put data in will automatically work out a whole litany of stats, things like sigma, variance, mean, all sorts of things. So that will be a key component. At the next TRG we are perhaps going to have Casio in to talk through. There is another calculator from Texas which we haven't had time to look at, but we have reviewed the Casio one and it seems to do what it's supposed to. There on the screen you'll see a few other things. Some of you will recognise in the middle an Excel spreadsheet. The large data set, which I'll mention later, all the exam boards have, is stored in an Excel spreadsheet. So students will need to be familiar with using Excel. We've used it a lot in core maths. The other things there that you naturally see are something called Geogebra, and we think this will be a key component in uses of technology in the A-level. So what do we have to do with technology? We know it's one of the 4 key themes. I don't know whether it's helpful or not, but we have to permeate our teaching with technology. In essence, that means, from a lesson point of view, I think just making sure that certainly we as teachers are using technology, and to a certain extent, so are the students. The actual summary of it is not particularly helpful, but for instance, calculators need to have an iterative function, and they need to have the ability to compute summary statistics from standard statistical distributions. In other words, they need to have the tables rather than having a separate handout. You'll need to look through the tables directly on your calculator. Okay, so for us, the two key things are probably calculators and something called Geogebra. I'm going to introduce Geogebra a little bit. You can just simply type Geogebra on the web and you can access a huge amount there. You can get it installed on your computer as well, but I've found in lessons I'm just using the online version. I mentioned earlier on about usage of Excel. For the applied stuff, particularly in mechanics, one piece of software that we use is PhET, which the PH effectively stands for physics in there, and graphics software, we naturally as a school use Desmos. Down at the bottom of that screen you'll see mention of the two calculators that seem to do everything that's needed for next year. The FX991EX and a version called the EX Wiz are the ones we've been using. We think maybe it's going to change, but they'll retail between £15 and £20, that order of magnitude, but there's probably bulk discounts and all
Actually,
that.
when I checked on Amazon this morning, I was quite shocked. The Class Wiz was retailing at £39, which seemed quite steep. I rather think Casio have overpriced it because a few months ago it was possible to get it on the web for 25. I think they're pricing it at a discount.
Yeah, so we'll give you an update on that, but clearly there's going to be a lot of people wanting to buy these calculators, and I would think, given the fact that Texas has a rival one, that we should see a bit of price pressure. Okay, so what have we got to do? We've got to use data in statistics, and in particular, if you can read that screen, it refers to a large data set. It also refers to spreadsheets and specialist statistical packages, and interpreting real data, so all the large data sets are real data, and we're required for students to explore the data sets. It's quite important to realize that in the context of the exam, the students will not have access to the data set, and it will be examples taken from the data set, and there's absolutely no reason why you can't do the exam questions standalone without having seen the data set. So it's not that you have to have done it, it's just that you'll have a familiarity with the data and the types of things you might do with it if you've seen it in prior lessons. So what is the large data set and what sort of questions can you be asked? So because we're primarily, to begin with at least, looking at Edexcel, they have helpfully in one worksheet given a summary of the sort of things that they might suggest that students are familiar with. So for instance, they've got to be able to calculate the mean and standard deviation, and they've got to be able to compare rainfall in 87 and 2015, etc. They've got to explore correlations, linear regression. Item number 4 there, I'm not entirely sure that will get through in the final sign-off of the spec, but it does refer to whether or not you can give any evidence of global warming, possibly a slightly controversial element in terms of statistics. It's quite an important element of that whole argument is the statistics, and maybe it's not something you can summarize just in one small set of data. And then you need to be able to generate suitable graphs. The type of data, so Edexcel has got basically weather data. It's got weather data at about 5 sites throughout the UK. It's got it in 2 different periods. It's got weather data in Beijing as well. And by weather data, it covers a range of things: humidity, temperature, rainfall, a whole range of things. I haven't had a chance to look at the MEI and OCR data, but it's the same type of concept, all in a spreadsheet format. And MEI is to do with the 2012 Olympics, and OCR, the local authority data. This is quite difficult to see, but this is the front page when you enter the Edexcel large data set. You can just download it from their website, and it explains all the data sources, cloud cover, visibility, pressure, etc. If we look at the map of the UK, you'll see there's 1, 2, 3, 4, 5 sites where you've got data. Now, interestingly enough, in a later session we'll talk about how the specimen papers look. But in one of the papers you were actually asked to analyse data from Heathrow and Herne, and to be able to recognise that Herne was more south than Heathrow, and therefore the temperatures might be higher. And actually in the exam format you weren't given that picture of Herne relative to Heathrow. Again, it's possibly early days, but I suspect that might not be in the final version. I'm not entirely sure. It's a geography test when our students do their S and A levels. Here's an example of what we've used with Excel, where you can just put in large data sets and automatically produce histograms. Here's an example. We're in the, if I can put it that way, in a process of upgrading to Geogebra. Here's a version on Geogebra. During the live session, I did actually show this, and I think, given the fact, partly because I'm not confident in the technology, I'm not going to try it now. But save it from me. All you have to do is type in Geogebra, and then you can automatically access things like this. All you do is do a search and type up normal distribution. Here's something that you can do from the Edexcel dataset. You can just copy in the data from a spreadsheet, put it straight into Geogebra, and it will automatically produce box plots for you. That happens to be some form of comparison of temperature data, the maximum temperature data, and you can see there's 4 box plots there comparing 2 sites, Leanin and Camborne, and then equally well comparing them between 87 and 2015. So in the spirit of global warming, you might just look at the medians of each data set in 87 and 2015 and see if the median's gone up. Maybe that's some measure of whether or not we've got global warming. Clearly it isn't, and it's much more sophisticated. But the point is you can easily access that data. Here's something we've been using for our GCSE. There I've got our students in Year 11 have just done 3 papers, and there, if you look at the scale, a bit difficult to see, but 0 to 80, it's 80 marks for each paper, and you can automatically see how the students did on each of the papers. An important part of exploring the data set is X's or outliers, and you might see that in the second box plot there are 2 X's on the upside. The 2 students that got those highest marks were very interested to see that they were marked with X, and it's simply because they're a sufficient way above the median structure box with their first and third quartiles, that they're sufficiently far away in some measure that maybe they could be regarded as outliers. Am I going on to problem solving?
Oh, that's right. That was what I. Okay. One of the changes in the content is students are supposed to learn about differentiation from first principles. When we handed out that starter sheet to everyone, they were all very happy about teaching differentiation from first principles. I'll unmute myself now, and I'll start again. You would remember from the sheet I showed you at the start that we did a survey of the teachers who were present. They were pretty confident about teaching differentiation from first principles, as I would expect. What I found interesting is when I looked at exactly what we're going to expect our students to be able to do from first principles, because it's a little more complex than I'd initially thought it might be. So I'm going to take you through what your students will be expected to do, and we'll look at some exam questions later, and it's quite interesting how they've changed between the first and second iterations of the specification. So, there you are. Let's differentiate principles. Now, in theory, our new students are supposed to have learned all of this at GCSE. They're supposed to have learned how to estimate gradients from non-linear graphs by drawing tangents, find approximate solutions numerically, and even look at the concept of instantaneous rate of change, which is what the Americans would call pre-calc, but it's right on the edge of formal differentiation. So this is the knowledge that our students beginning their A-level next year allegedly possess. Now, it's probably worth having a look at this. These are the relevant nuggets of understanding that we hope our students have. When I was going through this with people last Wednesday, I said, gradients of change, I hope they've learned that. Gradients of straight lines and gradients of curves, it's pretty straightforward to show them what a tangent is. They might have forgotten, but I bet they remember the word tangent. Compound units, as speed and unit pricing, they'll have heard of them. Might get a bit confused over some of them. This last one, if I had to ask you within 60 seconds to write down a definition of what that actually means, I wonder how you get on. And certainly I had to think quite hard and make a couple of passes at it. I would be very surprised if all but the best taught and very much the sharpest students will really have a notion of what the instantaneous rate of change is. So I'm assuming, and I've heard of this lot, probably won't have much understanding of that. That's what we'll have to teach. So, what's in the A-level? This lot. Understand the derivative of the tangent. The gradient of a tangent is a limit, nu. Derivative as a rate of change was always in, but they're doing a bit more with it now. Sketching the gradient function, second derivatives, all there before. Differentiation from first principles. So what does that mean we'll expect them to do? Well, here's how I taught rates of change to my GCSE students when some of my top students were doing additional maths a couple of years ago. I actually started off talking about price rates. I give them a price for some rice, they work out some numbers, they draw a graph, and then they answer some questions. Gradient of the graph. How much is a kilogram of rice? And then the bizarre question, what do you get if you divide pounds by kilograms? And what you get is this. And of course what I'm alluding to is 1 kilogram of rice, 2 times 50. Gradient of graph, 2.5. And that 2.5 is a rate of change. So I'm trying to link together the notions of a rate of change with a meaningful compound unit, a price per unit, and a gradient of the curve, a graph that they can understand. Here's another one that they will probably have encountered at GCSE. Once again, I go through the same routine. This could be a GCSE lesson, it could be a introduction to calculus lesson at A-level, but this was bridging the gap. Okay, once I'm happy they've got that, and that could be 15 minutes, it could be an entire double lesson depending on the students who are there, we go on to here. Now this is the end point of what we hope they have done at GCSE, where they will have drawn tangents and drawn little lines and got estimates for gradients. What's the gradient at this point? At this point, it is incredibly useful to flip into using Geogebra. And I think it might be worth just very quickly showing how you actually do that with Geogebra. So I'm just going to go to Geogebra Online. If you're watching this on video, I'm going to pause it because that's just a determinant term by the rate of our network connection. But I'm going to show you in real time how I can find a demonstration of this gradient thing that I can use on my computer. So, Norma. Right. So I want to introduce differentiation from first principles, and if you remember that screen I got to, what's the gradient at this point? Right. You get when you go on my Geogebra, I click on materials. That's where I go. I now go to differentiation from first principles. Search. And what do I get? Ho hum. Here we are. Now, I have looked at this before walking into the room, so I know that this is a good one here. I also didn't know the person who did it, trying to teach them. So here we go. I click on it. It all starts up as you are watching on Geogebra. Geogebra is not installed on this computer. I'm running this on the web. And what I'm going to do is I'm going to take out some of this junk, which is just confusing stuff. And I'm going to take that off, and that off, and I'm going to knock that off. So here I have a tangent drawn. Here I have a tangent drawn at a point. And what I can do is, if I make my point A here, I can drag it, and you'll see as I move around, the gradient of this thing is changing all the time. Now I'm just going to stick it, and Geogebra does this very helpfully, it's going to stick at 1. And what I'm going to do now is I'm going to find the gradient at that point. And the way I'm going to do that is I'm going to draw another point up here. And I'm now going to draw in a little triangle here, there, and there. And I'm now just going to use the GCSE technique. This is an estimate of the gradient at this point. It's actually the gradient of that chord there. It's 3 divided by 1. And if I zoom out, oh look, there's my gradient. And now, here's the bit I actually rather like. What I can do now is I can bring those 2 points together. And you will see that that gradient starts homing in on a sort of, oh, it's getting really, really close to 2, and then, this is why I like this particular demo. It doesn't cheat it and talk about what happens at the limit. But I have simply explained what we mean visually by finding a derivative at a point. What I'm looking for is what that limit, what's it getting really close to? It looks like it's getting really, really close to 2. Okay? Well, now I can go back to my presentation and I can say the gradient of the point is approximately this, which is that. Just doing some straight algebra here. Cancel out my 1s. Cancel that lot out. I get that. So that is exactly this limit here. I've just glossed over it. That would probably take me a few minutes to explain to a room of 6 formers, but I have just defined differentiation at first principles in the particular case of y equals x squared for the particular point 1, 1. Then, of course, we go to doing it generally. We talk about the rate of change when the graph is curved. And then we can ask them to do it for, say, x squared, or x squared plus 3x, or ax squared plus bx plus c. How about x cubed? Although small powers of x is all it says in the specification, I think we can be fairly confident that it's not going to go much above 3, because cubing things out of brackets is tedious. Beyond that is silly. Now, the slightly scary thing about the spec is it is not simply small powers of x. The specification also says differentiate sine and cos from first principles. Now that's fine as far as this definition is concerned, because they can get to there simply using AS maths. The problem is they can't now get any further unless they know how to expand sine of a plus b. And traditionally, they don't do that till C3, do they? So if you're going to teach them this, traditionally differentiating sine and cos didn't come up until A2, you're going to have to think very carefully about when you do it. So okay, you've taught them sine of A plus B, so you can now plough bravely on and do this. And then you do this rather nifty bit of reorganizing, which is a bit of a trick, but it's still just algebra. But then I've now got two different limits. We know we are looking for the derivative of sine x is cos x, so we want to convince ourselves that this thing becomes 0 and that that thing turns into 1. Well, that's fine, provided we know that is the case. And what I've just written down there, cos x tends to 1 minus x squared over 2, and sine x tends to x for small values of x, those are the two limits that they are supposed to know in order to solve this from first principles. And that, for those of you who know further maths and who know the Maclaurin expansion, will instantly recognize these as simply the first two terms, actually the power of 0, the power of 2 term, and the power of 1 term, the Maclaurin expansions for cos x and sine x. But Maclaurin expansions were year 13 further maths, if you've taught that, not something we would generally teach to our A-level students. So we're going to have to think very carefully about how we do that, because that is in the spec. And once you're happy with that, you can then go all the way through and say, well, we know that that thing there, obviously as this gets very small, just tends to 1 minus 1, so that's 0, and delta x over delta x, that's going to tend to 1. We just get that. But this last bit here involves a fairly nifty use of limits. And certainly when I did that with people on Wednesday, some of them gulped slightly and thought, gosh, teaching this to all our A-level students, probably need to think a bit about that, about how we're going to finesse that particular thing. Thankfully, that's the end of the line as far as differentiation from first principles is, but there's a little bit of thinking to be done about how far we go, how fast we go, and where we expect all our students to get to on this kind of stuff. And that is it for differentiation from first principles.
Oh, beautiful.
So now I'm going to hand back to Lee to talk to you a bit about problem solving. And Lee, what I might be doing is maximizing your Adobe Acrobat screen so that we're not seeing the edge of your screen on our screen. So if up there, you maximize that one up there.
Maximize this one?
Maximize that one there. Yeah.
Okay.
And then it just makes it a bit clearer in our screens.
Good. Thank you for that technology tip, Nick.
Yep.
Okay, so I mentioned earlier about I think a really fantastic document. We've got it available on PDF, or you can easily download it from Ofqual. But A-Level Mathematics Working Group, which came up with elements of what constitute problem solving. And I'm not going to go through the details, but I thought it was very, very impressive. The sort of elements that go into it. There are 6 that they came up with. The first one is probably one that we'd naturally sort of think of. Tasks have little or no scaffolding. That is, students don't necessarily know where to start, and they need to work through the sort of techniques that they've learned and what they might apply. But there are 5 others. From what we're understanding in terms of the original specifications that went to Ofqual to be ratified, it seems as though a lot of the problem solving submitted by the boards effectively had all 6 of these elements in what maybe the exam boards thought of as problem solving, whereas in reality it sounds as though really it can be as little as 1 or 2. There's really no set number, I think. But I think what we were hearing, I can't really corroborate it, just talking to people, is a sense that if you put too many problem-solving questions in, it means those weaker students, for which read maybe E-grade students, are really not going to be able to access the questions. So later on I'm just going to show you my assessment of one of the specification papers. My assessment of it in terms of how difficult it is and how does it change from the old specification has changed from the original spec I was given. I would have said almost every question was problem solving, And when I show you the example, I think the new input for the A-level doesn't really come through to as late as something like question 9. I definitely recommend, however, looking at that report. Okay, I think it's important to say, I teach a year 11 top set at the moment, and we've just been going through mocks. I think it's very important to say that within the new GCSE, there is a whole element, at least in what we're seeing in terms of mock papers, specimen papers provided certainly by our exam board at Excel, a high level, I would say, of problem solving already. If all my students have got everything, big if, then I would think they'll be really well prepared even for an A-level that's changing. So I actually think there's a strong positive behind what we're possibly seeing with the change in the GCSEs. I do think there'll be more of a mindset towards problem solving. And why do I think that? Well, we've just been given a mock that we use from Excel. We're waiting to properly see grade boundaries, but if anybody's interested, we're happy to talk through where we think the grade boundaries are. Here's something, a vertical cross-section through the center of a bowl. It's got elements of modeling, it's got elements possibly of problem solving. You've just got a curve there that describes it, and you're asked to find the depth of the bowl. So you can do it through completing of the square, I think. But of my students, of which I imagine quite a few hopefully will do well and get grades 8 and 9, I would say there's only really one student out of a class of 25 that realistically got that one. So I think that's quite interesting to me because there's elements there that you need to understand the idea of completing the square to really sort of see your way through that. Here's some others that came up. We've got fish in a lake, and the number of fish halves over 8 years. So all you have to do is put r to the power 8 equals a half, and then you get that, and then you do r equals 1 plus x% to work out x%. Well, that's quite a tricky one, I would suggest. Again, based on my class, a very tricky one. And then the proof structure, the areas that Nick's highlighted a little bit. In the Excel mock, you had to prove that the quadrilateral formula in terms of opposite angles add to 180. And yes, all of those can be proved by a sort of structure of drawing radii from the center to the vertex, and you are shown a center there. But nevertheless, that's quite a tricky problem, I would suggest. Here's an even more tricky one. Here's something where you calculate lengths, but you then don't use them, so to speak, because you have to end up doing an angle. This happens to be some form of tetrahedron, pyramid. It happens to be right-angled, so you've got to do a whole series of linked trigonometric ratios. You've got a plane surface to consider. I don't know whether you can see that, a plane ABC. So an awful lot in that. Some of my students actually managed to work their way through it, but it's what I don't know if anybody's seen the trigonometry pile-up questions. It's very similar to that, where you had to do one thing to calculate another, and then move on to another, and so on. Quite a tricky problem, I thought. Now, what I was going to do now was just to show from the working group some of their problem solving, and then show how that looks as though it's coming up in the draft specimen. So in the book from the working group, the report, they've got a whole series of modelling, but what perhaps caught my eye the most, for modelling and problem solving, I tend to use them interchangeably, although in many respects they overlap, but they are distinct. Here's a question which, if you go down to the bottom of the page, you will see something that looks a bit like that example I just showed you of the GCSE. You've got an equation n equals minus something s squared plus something s. So again, it's a completing the square. And so the traditional questions would be C down to E, but to get to your quadratic equation, you have to go through reading a paragraph and work out the concept that if you're queuing for lunch in a college, maybe if more and more people queue, the service gets slower, in which case you're less inclined to perhaps go and take your lunch, and the number of people served is therefore not a linear relationship with the number of students attending the college. So there's quite a lot in there which once you work through, I think is very, very feasible, and there is some scaffolding in there, but it is quite a difficult process, I would suggest. Another example is something that reminds me a little bit of UK Math Challenge or something. You're given some straight lines and a circle, and then you just need to, all you've got to do is find the equation of that line going across with a negative gradient from B to A. That's all you've got to do. So it's a y equals mx plus c, or y minus y minus x minus x1 equals m, or how you like it. But you've also got a circle involved. Very helpfully in the report. I mean, it's lovely to do as a challenge, but there is a sort of mark scheme and methods of how you might be marking it. I don't know whether you can see. There's a method 1, a method 2, a method 3. Definitely what we're finding in the GCSE, Edexcel have introduced a P mark standing for process, if you can identify the right sort of processes. But clearly there are multiple ways of doing questions like this, so it can be quite tricky. So that's problem solving and a little bit of illustrating modelling. What I decided I might do was, we've got specimen material. It's not been signed off yet. So we don't know how it will change, but what I've done here is for Edexcel, the students will have 3 papers at the end of their 2-year study course, assuming they do it over 2 years. There's no reason why you can't do it over 1 year. But if you do it over 2 years, you'll have 3 papers, each of 2 hours. This happens to be the first paper. Nominally, in the language of current A-level teachers, you probably call that C1 and C2. First 10 questions, I thought, in the modified version we've seen, are fairly standard. Question 11, there's what Nick was saying. It's a question from first principles. It does give you a little bit of a lead. You may assume the formula for sine A plus B, and you may also assume those limiting conditions as h tends to 0. But you'll see, immediately there's clearly that new input of differentiation from first principles. And you'll see, this is available as a report. What I've done is try to give my model solutions, hopefully they're right. And then I've made a comment at the end of each question as to whether or not it's new or not. So that was the first principles definition. I'm just going to move on a little bit. You're welcome to look at this at your leisure and check. An archer shoots an arrow. And this is sort of reminiscent of some of the stuff we've been seeing earlier. I've got a quadratic there. The maths is going to end up solving that quadratic, but I need to use that formula in various ways and recognise that h is some sort of height above the ground and d is a horizontal distance, the sort of stuff that we're fully aware of. But if I go down towards the end of the question, you'll see as I work through, you've got to look at a significance of the 1.8. This is part B. That happens to be the height from which the arrow is shot. That's something that's a little bit new. It's started to be in the GCSE in terms of interpretation of gradients. It's not saying the gradient is 1.2, but saying every minute something happens, something goes up by 1.2 or whatever it might be. Part C, not particularly helpful. You've got an A, B, D, and C. A, B, and C to work out. So not too much scaffold in that, but sort of completing the square, isn't it? And then lower down, you've got a 2.1, and you've got to, in essence, look at that 2.1 relative to the 1.8 that we had in the previous one. So you can think of that in transformation of graphs, you can think of it in a range of things. But nothing new there in terms of the maths, but there's definitely more of a thought process that needs to be applied. So that one, I say, is modelling of a quadratic, non-integer numbers. You've got to interpret parameters. You've got to complete a square with 3 parameters, not just 2. and obviously you need to know a bit about mechanics of projectiles will probably help. It should be said that on the applied side, there is a linkage directly in both the mechanics and statistics to be able to use pure methods. So there's a direct link. So for instance, the mechanics, they deliberately put in calculus in terms of working out acceleration as dv by dt, etc. So there's a deliberate attempt to say that you shouldn't really be teaching these in silos, that you've got to link together the pure and the applied. Interesting enough, edXL as an exam board has put them as silos in their papers. Paper 1 is, if you like, C1, C2. Paper 2 is largely C3, C4. And paper 3 is putting together half statistics and half mechanics. Other boards have taken a different view of the integration. Here's something that's new. You need to be able to do log-log graphs. I remember doing those x times 10 years ago, where x is quite a large number, probably at the same time that we were using slide rules, but that's back. It's obviously used in science for working out various exponents, but you will now need to use to do log-log graphs and to be able to work out gradients and the interpretation of y-axis intercepts. So that's a new area as well. But the maths, of course, is, you know, how can you use logs effectively. So that one, modelling structure, because it happens to refer to bacteria. Exponential happens to be, you need to know log-log graph and interpretation. I have heard that possibly Ofqual's a bit worried that there's a bit too much sciencey stuff in some of the specimens. So we'll have to see if that sort of element comes into question. There's no reason why you couldn't do that question without studying physics, chemistry or biology. It is standalone as maths, but nevertheless perhaps it prejudices those not doing maths. And I think those were the sort of key elements. As I say, we will, that full report with all my model answers is available. I've also got it for some statistics questions. Just whilst I'm looking at it, I've happened to have gone to question 16. Looks a bit like the Trapezium Rule, I think I'm right in saying, yeah. The Trapezium Rule, by the way, is now in GCSE. It's not called the Trapezium Rule, it's called estimating the area under a distance time graph, but it just so happens in the questions that have come on the mock, it's clear you have to divide into strips and work out area, and possibly the easiest way is doing it as trapezium, but if you really want, you can do it as a rectangle and triangle. So that just, for me at least, reinforces this element that actually I think many of the students coming through the GCSE will actually have been primed with some of the elements to enable them, hopefully, to successfully go on to the A-level without those same type of issues that perhaps our current cohort would have, our Year 12s, if we were to put these questions in front of them. I think we do plan to put some of them in front of our Year 12s as a sort of test just to see how they react, but it's not a hugely significant thing for us. The final thing I had just was textbooks. If you've been teaching core maths, you'll know we had a frustration of having to teach without textbooks at all, and they basically came out for not quite a week before the exam, but at least we had one just before the exam. edXL, Pearson, and you'd expect they've got a plethora of books. You can get one for each exam, you can get them for the AS as well, all sorts of things. And I think for edXL, OUP are doing something which has everything in a single textbook. So here's everything for the A-level student in Year 1, here's everything for the A-level student in Year 2, and similarly for the AS. The sense we've got is a lot of these textbooks are ready to go once the specifications are fully in. So I would expect us to see a little bit of headway on that, hopefully in the next month or so. But certainly by March or April, I would think we're going to get specific textbooks. What we did for core maths was we signed up on Amazon for the textbooks. I think you can sign up with the exam board as well, but that was quite a good way, and it was quite nice when in the mail I suddenly got a core maths textbook out of the blue. So that's worthwhile thinking. But from our point of view, I think we feel fairly comfortable, although our teaching style may well adapt to use pervasive technology to think about ideas or presenting problem solving. Actually, it's still nice to have those textbooks for the range of examples. That's sort of concluded my little section. I'm going to pass back to Nick. So all I've got to do is find the right technology, Nick, first, switching it back to you.
If you go to attend, if you go down to attendees and just you can right click on me and click make presenter. And just
thank you very much for listening. I'll be on the end of Nick's bit now if there are any questions.
Well, that pretty well wraps it up. The things we wanted to look at were the shape of the new A-level problem solving, how it relates to exams, with a slight focus on this business of proof and differentiation from first principles. We've done that now, and I think that recording is around about 45 minutes, which is quite enough to ask anyone to listen into. Our next A-level session is planned for, I'm just getting my diary out, I should have this to hand, but it is March the 8th. Now I'm hoping that by March the 8th we will have had the Smith report, so we will know where we are with the relationship between A-level maths and core maths. We will have had the specifications signed off, and we have some specimen chapters, if not specimen complete textbooks. So I'm hoping we will be quite a lot further down the line in terms of the raw material we will have. If I go back to the things that were concerning people at this session, one particular individual was extremely concerned by the language in the exams and was very concerned by her ESL learners, particularly when the people were talking about archers. No helpful picture there. If you're not fluent in English, you might not know what an archer is, in which case it's very hard to make any sense of what all those variables might mean. We've got no immediate answers to that one, I'm afraid. However, as a sort of broad answer to the concerns about things like schemes of work, I think what I've noticed in the way people teach A-level maths generally, I sometimes think as we go up through the years, we become less and less inventive in the way we teach. Key Stage 3, we do all sorts of wacky things and use things from standard units and have them do card sorts and all that sort of thing. Key Stage 4, we say, oh, well, you better buckle down and do the GCSE, and then they start doing nothing but practice papers at the end of year 11. And then A-level, particularly if you're doing the EdXL A-level, those textbooks are such fantastic revision guides that you end up working through, to some extent, a super-duper revision guide for the duration of the course, or can do if you simply work off the book. Now, I think the two issues that came up headlined links to the new GCSE, which we've addressed in part, and schemes of work, which we haven't really looked at all. The schemes of work question, I think, will become easier to answer once we've seen the textbooks, because I think broadly what teachers will do is they will look at the textbooks and then formulate their schemes of work around those. I think one of the big questions that we need to be looking at next time is how do we link this funny nebulous problem solving thing into our traditional schemes of work? Because the traditional A-level schemes of work means it's week 2 of the A-level course, therefore we're coming to the end of chapter 1 on surds, and next week we move on to quadratics and completing the square. I don't think, given the priorities of the new A-level to embed problem solving and technology, that is going to be the optimal solution in terms of how to plan a scheme of work. However, I do think there will be an element of, if it's week 4, it's chapter 6, and it's how to interleave those two aspects of the course, which I think we've learned quite a bit about through teaching core maths, is to some extent where the questions need to be asked, and it will be a lot easier to address those directly when we know a bit more about the books. So I'm hoping we can look at that a little bit more in the next session. But other than that, that's all I've got to say. Lee, if you've got anything to add, we can sign off now.
No, just thank you very much indeed for listening, and please just if you need any information or any documents for some reason haven't reached you, please do just email us, and any comment, negative or positive, in terms of the content and or what you might want in the future, please do keep us informed, because we're very conscious we're trying to provide stuff outside what the main exam boards will be doing, which I've found quite helpful when I've gone along to a few sessions, but we're trying to focus very much on teaching practice. But thank you very much indeed for listening.
And to get in touch with us directly, either one of our emails will do. That's mine, Nick Kivers, and Lee's is l.baxendale at stmarylebonschool.com. So you can certainly get in touch with either of us on those two emails. Get in touch with us after this. We will be, as I say, I'll be emailing you all with the next session, with more information about that in 3 or 4 weeks' time. And I hope to meet you again on or offline soon. And I'm going to stop the recording now.